All right, so the first thing you need to know about today's lesson, we're going to be talking about complex numbers, and we are looking at I equals the square root of negative 1. In other words, I could take both of these and square them, and then I would have I squared equals negative 1. That's something else you should know. Okay? So anytime you see an I squared, it is equal to negative 1. Very good. So we need to show that the square root of negative 5 is I square root of negative 5. So I'm going to actually go about this backwards, because if this is the square root of it, if I square it, I will get negative 5. So let's try that. So that means this is going to be I square root of 5 times I square root of 5. Okay?
Is it times the square root of 5 or is it raised to the square root of 5?
Nope, this is to the second power. So I'm multiplying them both. Yes? Not yet. We're not there yet. I'm working my way backwards. Okay. So then I could put my i's together. So I times square root of 5 times square root of 5. So this would be I squared. And what is square root of 5 times square root of 5? 5. And we already know that I squared is what? Negative 1. So negative 1 times 5, which is negative 5. Okay, so I needed to work my way backwards. What I did is I showed that the square of this is negative 5. So therefore the square root of negative 5 is this.
So could we leave our answer as negative 1 times 5 equals negative 5?
Yeah, right here. So
This is going to take me a while to understand. Oh, I see.
all right, so on this, the first thing you need to know is that when you are multiplying a square root times a square root, what is this supposedly going to be?
4.
So like if I had the square root of 2 times the square root of 4, what is that normally?
The square root of 6?
Square root of 8, right? Normally. But I need you guys to know that that is not true when you're doing imaginaries. And I'm going to show you why. This square root of negative 4 is the same thing as saying
I square root of 4.
it's I square root of 4, which happens to be what?
Negative 4.
What's the square root of 4?
2.
2i, okay? And this one is going to be the same as saying I square root of 16, which happens to be what? 4i. So if I multiply those two together, I get 2 times 4, which is what? 8i squared, which happens to be
Negative 8.
negative 8.
Wait. But I...
What is negative 4 times negative 16? Negative, square root of 64, right? What is the square root of 64? It can be positive or negative 8, right? But over here we got a negative 8. Here we got two different answers. So this is the reason why we are doing this right now, just to show that the square root of A times the square root of B does not equal the square root of A times B with imaginary numbers. Okay? I can't do this over here with the negatives. It doesn't work. You have to do it the long way with the eyes.
So whatever you did for me just now is wrong?
Yeah.
Okay.
Okay? So this is the only way you can do it with imaginary numbers. You cannot do it this way.
Well, you can't do the box way.
What I just did. Multiplied negative 4 times negative 16.
You have to take out the I.
You have to take out the I first. Okay? It's partially correct. Okay. Right. Okay, so definition of a complex number. A complex number is a number of the form a plus bi, where a and b are real numbers and I is an imaginary square root of 1, negative 1. Okay? So now, this one it says solve x minus 2x plus 7. We are going to use our wonderful formula called the quadratic formula for this. So you guys better write it down because you need it. And by the way, this is one of your methods for factoring that you should mention in your tree diagram later in the week. It's due by next Monday.
Like what it is.
My A value on this is what? 1. What's my B value? And what's my C value? 7. Okay, so for this one, I'm going to put negative 2 plus or minus the square root of negative 2 squared. Notice I'm using parentheses. That's a very much a safe way of doing this. If you do it without parentheses and your calculator, you're going to be sorry. Okay? Any questions about how I put that on there?
Why is it plus or minus? Is it 2?
It's not us. The other people back there.
So either
Notice that when I add all this together here, it's a negative 24. Okay? Basically, I added this. Okay? So negative 2 squared is 4 minus 28. 4 minus 28, I mean, is a negative 24.
Shouldn't you do 2 plus or minus I square root of 24?
So I'm not there yet. Okay? So now what can I take out of here?
Wait,
Should that be negative 20? It should be negative 32.
No, because a 4 minus 28.
Why minus?
Because this is negative here.
Oh, I
So wouldn't it be
forgot.
negative 4 times?
Never mind.
No, because negative 2 times negative 2 is a positive 4.
2 squared by 2
So if I take 2 plus or minus I, and then I have square root of 24 here over 2. Now, we need to reduce this. What are my prime numbers of 24? How can I reduce it to all of its prime numbers? What goes into 24? 6 and 4. So 3 and 8, 2 and 4, 2 and 2, right? So 2 times 2 times 2 times 3. That's 24 in its prime numbers, correct? So what I can take out is a pair. I have one pair of 2s, correct?
Correct.
Okay. So now this could be, that means I could take that out of the square root. So I have 2 plus or minus 2I square root of, what's 2 times 3? 6 over 2. So notice they all have 2s. So what can I do? I can cancel out the 2s. I can divide each one by a 2. Okay? So 2 divided by 2 is 1. 2I divided by 2 is I square root of 6. Okay, so now this is going to be, if I'm going to find this one, I need to get everything to one side of the equation here. So I'm going to change this. I'm going to take away a 5z from both sides. Yep. Okay. So now at this point, I have A equal to what in this case? 3. What's B? Negative 5. And what's C? 10. Okay, so we need to put that into our quadratic formula. Okay, so this will be a negative 5 plus or minus the square root of negative 5 squared minus 4. What's my A again? 3. And my C is 10 over 2 times 3. All right. So, negative 5, what does that make that? Positive 5. So, plus or minus the square root. And if I go through all this, this will be 25. I'm going to change my color here just so you guys see. This is 25 right here. Negative 12. So, minus 120. So this will be a negative 95 in here. Okay? That's all going to be over 6. Okay? Now, what can I take out of my negative 90? An I, right? So I have 5 plus or minus I square root of 95 over 6.
And then you have to find the factors of 95.
So let's look at that. What are my factors of 95? I know 5 goes into it, right?
5, 9, 5, and 19.
5 and 19. Now, do I have any pairs? No, they're both prime, so I can't take anything out of that. So my final answer on this one is this. I can't reduce it at all. That one was a lot easier. Okay? So a pair of complex numbers like this one right here that I just showed you and this one up here, that's a pair of them because it's got a plus and a minus. They are called complex conjugates.
Wait, if there's a plus and a minus.
Yeah. So example of that from the one above, we got 1 plus I square root of 6 and 1 minus I square root of 6. Those are conjugates of each other. Okay? Yeah. Okay. On the next page, the first part of this is now we're going to be looking at operations with complex numbers. What do we do with them when we need to add them together and so on? Okay? So Z is 4 plus 5I. W is 2 minus 3I. So we need to add these together. So I'm going to just write them out. We have 4 plus 5I plus the W, which was 2 minus 3I.
Then can't you just do 6 minus?
Exactly. You're going to put the non-i's together, which is 4 plus 2 is what? 6. Okay? And then I'm going to put the i's together, which is 5i minus 3i is plus 2i. Okay? That's it.
That's all we do.
Okay? Now, on the next one, we're going to do the same kind of thing, but we have a negative here, so we've got to be careful. We have 4 plus 5i minus, and I'm going to put it in parentheses so I can make sure that everything gets that minus sign. Okay? So in other words, this will be 4 plus 5i minus 2. What does this become? Plus 3i. Okay? So now I can put my non-i's together. What is that? 2. Okay? Plus
Plus 8i.
8i. Good.
My age.
Because 5i plus 3i is 8i.
Yeah. Oh, not 2I, just 2.
Mm-hmm.
Oh, sorry.
That's okay. All right.
Oh, God.
Now we're going to multiply them. So this one gets a little tricky.
Is this where you foil?
You can foil, or I'm going to use a box. Okay, so here's my box.
I never learned that.
Well, now you can.
You need to talk to Mr. Boone about
So Z equals 4 plus 5i. Here's 4 plus 5i right here. Okay? I'm going to put the other one on top here. So that's going to be 2 minus 3i here. So on the box, what we do is we multiply our top row by our left column. So 4 times 2 is what? 8. So I'm going to put an 8 there. What is 5i times 2? 10i. Okay? On this one, what is 4 times negative 3i? Negative 12i. And then what is 5i times negative 3i? Okay, negative 15i squared. Yep, now it gets interesting.
So then wouldn't it just be 15?
Yeah.
So wouldn't it just be 15?
Oh, yeah.
So yes, this becomes a 15 because I squared is negative 1, correct? So let's go through and figure this out. So I'm going to write this in red over the top of it just so I can remember that becomes a regular positive 15, okay? So I have 8 plus 15. Those two can go together. And then I have a negative 12i plus a 10i. What does that end up being?
23 plus, or 23 minus 2i.
Yep, 23 minus 2i is my answer. Okay? Something happened. Okay, Z divided by 2 actually.
Oh, it's a 2?
It's a 2. Okay, so Z divided by 2. I'm going to write this as 4 plus 5i divided by 2. Okay? That is the same thing as saying 4 divided by 2 plus 5 divided by 2i. What's 4 divided by 2?
5 divided by 2i?
Mm-hmm.
Oh, not 2i, but 2.
So this will be 2 plus 5 halves I. That's it for those 4. Okay? I want you guys to take a minute and try to do A, B, and C of the next problem, and then I'm going to put my answers up and see if you guys have the same ones, okay? Sorry. Okay, so on this one, what can I put together? First of all, what are my non-I's? What are my non-I's? Okay, so I'm going to put those together. 1 and square root of 3. Okay, and the other ones are my I's here, so I'm going to put these two together, this one and this one. Okay? Plus 2i plus 5 square root of 3i. Okay?
Can't you do I5 square root of 3?
Yeah, you could do it that way too.
Feels like I.
But here's another way you can write this. You can actually write 2 plus 5 square root of 3 on the inside and put the I on the out.
Or can we not?
Hmm?
Can we not write that?
Actually, you should write this down.
No.
So this is the final answer. There's nothing you can do with it. There's nothing that can be added. But I put my I's together and I just pulled the I out. Okay?
Would it still be right if you just said option with the 4?
Like this one right here.
Yeah, you might have pulled the I one.
Yeah, that's still correct.
Okay.
But when you go, if you should ever take a multiple choice test, they're probably, because the standard form would be to pull the I out.
Pay for it before you can bring it home.
Okay? So let's do the same thing with z minus w now. Okay? So we have square root of 3 plus 5 square root of 3i minus, and remember, if we got a minus, we got to put everything in parentheses. So we have negative 1 plus 2i.
No, I'm lost.
Okay, so what happens to all my signs on the inside of this? They reverse. So this will become a plus 1 and a minus 2i. Okay, so let's put all of our i's together and all of our non-i's together. So we have, not really, it's going to end up being very similar. Okay, so this will be 1 plus square root of 3 over here, plus 5 square root of 3 minus 2, and then I'm going to put my I on the outside.
That's it?
That's it. Okay, we got one more to go through. Okay.
4 on the outside of the sequence.
Yep. So you're going to put the 4 on the outside. Square root of 3 plus 5 square root of 3i. Negative 1 plus 2i. There. Okay. So we can use our box to find out my two parentheses multiplying. Okay.